What's going on, everyone? Today we'll be doing another Leetcode question, valid mountain array. Let's get to it, see how we do. Return false. Okay, makes it better. Let's see what it says now. All right, cool, nice. Got it done. All right, I got a Leetcoin, I guess. Completion streak one day. Awesome. All right, so this was a success. Not the fastest, but it looks like it was accepted. So I'll look at the solution and kind of recap. All right, so let's go over the solution here that I've created. I'll just quickly walk through this. It wasn't too difficult, so hopefully it's not too complex for you to follow. But let's look at it. So at the first, we want to always do some validation. So if the array is null, then we return false, or if array length is less than 2. So if you remember in the examples here, if the array was ever 2, we can't have a mountain. A mountain needs at least 3 data points, right? We need like a low, a max, and then the right side with another low, because we're going up and then down. So you can't have only 2. So if it's less than 2, then we return false in that case too. Okay, and then my algorithm wants to find a max first. I thought that would be really helpful. So I first find what the maximum value is. So I do a linear scan across the array, and I do math.max with each of the numbers here, and I find the max value and set it in this variable. Okay, and then this is a special if statement. I need to make sure that the max is in somewhere in the middle of the array. It doesn't have to be right in the middle, but it cannot be the first element and it cannot be the last. So this checks to make sure that the first element in the array does not equal max, and then that the last element in the array doesn't equal max. So if they do equal, then we're just gonna short circuit, return false right away. Great. All right, so the next one is declaring the previous integer variable that we'll need. So as we're iterating through the array, so as we're going through here in this next for loop, we're going to need to reference what the previous one was, because we need to see if it's strictly increasing or strictly decreasing depending where we are in the array. So I'm going to first set the previous to array size 0, and the reason this will always work is because we've already done some validation up here, so we know there's at least one element in the array, or in this case we know there's at least 3 elements, right? All right, so then we have a Boolean is upslope is true. So this was a idea that I had to figure out if we're on the upslope or if we're on the downslope. So a mountain, you always need to start at the left side here. So you're always going to be increasing. So that's why we've defaulted it to true. So upslope is equal to true. All right, and then we'd have a for loop here. This is where we do all the magic of actually figuring out if this is a mountain array or not. So it's just a typical for loop that we're going to do a full n linear scan across the array length. So we need to check every single element and make sure that it follows this pattern. All right, so we have int cur, which is the current element here. I put 3 here because I was experimenting here. And also another thing to note, I'm not starting at 0 because we've already inserted 0 in our previous. So that way we can start at the second element, which is index 1. So cur actually, if we were in this case right here, the 0, 3, 2, 1, we are starting at 3. Okay, so then we have an if statement here. This is the upslope scenario here. So this if block is all about the upslope. So we're checking to make sure that we're strictly increasing. So if cur is greater than previous, so remember we've already set previous here, so that would be 0 in this case. So if 0 is greater than previous, which is 3, which it's not, right? Oh, sorry, it is, because cur is 3 is greater than 0, 3 greater than 0. And upslope is true, so that means we're still on the upslope. So then if that condition is good, then we need to do a quick check here as well to see if we're at the max value. If we're at the max value, that means we need to flip the Boolean is upslope to false, so that means we're now on the downslope. And then we have previous is equal to cur, because we need to now have the current one be the previous because we're incrementing through the array. And then I say continue here. We'll jump back up here and execute the for loop. And then I have an else if here. If cur is equal or less than the previous, and we're still on the upslope, then we just need to return false because it cannot be a mountain array. So this case right here, this where my pointer is, this red array, that would get caught to this point, right? Because we would be strictly increasing. Slope is upslope would still equal true, but cur would equal the previous in this case. So 3 would equal 3, and then we would return false there. So hopefully that makes sense. Okay, and then once we hit the max, so let's say we do hit 3 here. Once we hit the max, we set is upslope to false, set the previous to the cur, then continue, and then none of these scenarios here will get hit, right? So I can close this. Okay. Doesn't look that good. Okay, and then now we're in the downslope scenario. So if cur is less than previous, so now we're at 3, is 3 less than, or sorry, cur is now 2, is 2 less than 3, it is, and is upslope is false. So we're going to say previous is cur and then continue because that's a valid scenario. Else if the cur is greater than or equal to previous, so let's say that this is 5 or something. So in this scenario right here, if 5 is greater than the previous one and we're on the downslope, then we return false right away. So this will keep running through all the scenarios, and it'll drop down here if it's incorrect. So that's what I like about it. It'll return immediately. If it's incorrect, it doesn't have to run through the entire thing. It'll kind of short circuit. It'll figure it out early on, fail fast kind of thing, and then it'll return back to the caller. But anyways, if it goes through the whole array and the architecture of it, the rules, I guess, of it follow the mountain array pattern, then we'll go down here and return true. So when I submitted this earlier, I don't know why it's a lot faster now. Maybe I took out a system print line, but yeah, it was like 10% earlier. For some reason, it's way faster right now. So that's cool. So actually, this is a very fast algorithm. So there you go. And I'll link the code down below, and let me know if you have any questions or any feedback on it. So thanks a lot, everyone. And I'll continue posting these videos because I'm really trying to get better at software engineering to become the best software engineering leader that I can. So I hope it helps you, and we'll see you next time.